Now we're going to look at the surface area of square pyramids and cones. Now I put this as a separate section because these two need a little bit more thinking, okay? But as long as you get the diagram, it's again very easy. So let's try with the we'll start with the square pyramids. Now as you can see, this is what the square pyramid look like. The base is a square, and these triangles, they all meet at a tip or point, which is called the apex. So make sure you know that term. This tip is called the apex. And now this height, this length here, which is basically the height of the triangle, because it's slanted, if you look at the square pyramid as a whole, we call it the slant height. Okay, now this word will come out quite often, so make sure you know what that term means. Alright, so now you look at the diagram, and I'll go on straight to the surface area. Now, this is what the surface area formula is, but again, as long as you understand the diagram, as long as you look at the diagram pretty closely, you don't really need to memorize it, okay? Because you can just look at the diagram and consider it for yourself. So, I'll show you what this one means. This is 4 times LS over 2, okay? Basically, guys, as you can see, there's 4 triangles, 4 identical triangles, since the bottom is a square. Okay, so there's 4 identical triangles, so if I multiply the area of one of the triangles by 4, I'll get the surface area of the outside parts. So as I said, the area of the triangle is half times base times height. Well, base here is L, the height here is S, which is we also call the slant height, so S. And then we divide that by 2, or times it by half. So I'm dividing it by 2, and there's 4 triangles, so simply multiply by 4. Okay? And then you add the base square, so L times L, so L squared. That's pretty much it. Alright, so square pyramids, I think it's actually pretty simple. Now with cones, this is what a cone looks like. So it's a pyramid where the base is a circle. So it's like a circular pyramid, but we call it a cone. Okay, and again, this height here, because it's slanted, this length here, we'll call it a slant height, and we'll label it as S. Okay. Okay, now this diagram shows us the cone opened up. So we're basically showing you a net of the cone. All right. So see the outside curved part of that cone? If I open that up, this is what it's going to look like. And if you have a piece of paper like that, and if you fold it back, we'll curve it back into shape, you'll get something like a cone, isn't it? And of course the base is a circle, so that's the circle, which is the base. Now, this curved part, we call it an arc. So this arc part, this area here, okay, and this area here, if we add it together, we get the surface area of the cone, as you can see. So we all know this area of the circle, pi r squared. Now this is the new part, pi rs. This is the area of this part, okay, this curved part of the cone, okay, pi rs, where r is the radius of the base circle and s is our slant height, or basically this length here. Okay, so when you want to find the area of this part, you need to know the radius of the base circle as well as its slant height. So 2 parts you need to know. And this is something new, guys, so you've got to memorize that. So this one is something that I want you guys to memorize, the surface area of a cone. Okay, so have a look at that, look at it closely, write that down somewhere, and let's try some questions. Question 6 says, find the surface area of the following square pyramid. That's our square pyramid. We know that that's the formula. Okay, so I'm going to go ahead and put our values in. Our L is our length of the triangle, and S is our height of the triangle, which is going to be the slant height, 12. We divide that by 2 because that's the formula for area of a triangle. We multiply it by 4 because there's 4 triangles, and we add it to L squared. So basically, the 2 sides multiplied together to get the area of a square. So I'll put in my values. L is 10, S is 12, and L is again 10, so 10 times 10. You add it up all together, multiply it and add it up, you should get 340 centimeters squared. Okay, so this one is actually really straightforward. Okay, question 7 says find the curved surface area of a cone of base radius 8 centimeters, perpendicular height of 15 centimeters. Okay, so this is our radius of 8 centimeters and the perpendicular height is the distance from the center of the circle up to the apex. Okay, so it's the vertical height. Alright, let's go ahead and find the curved surface area. Well, first of all, see what I'm doing? I want to calculate the slant height. This is the slant height. Okay, remember, our curved surface area, we need to know the slant height. So we need to first find that, but because we don't have that, see what I'm doing? I'm using Pythagoras. Because see how this part is a right angle triangle? So we can go ahead and use the Pythagoras theorem. So s squared, the hypotenuse squared, is 8 squared plus 15 squared. And to find s, we simply square root it. Okay, 8 squared plus 15 squared is 289. If you square root it, you get 17. So our slant height s is 17. Okay, so now let's go ahead and find the curved surface area. Area will be pi r s. Okay, I told you this is a new concept, so you're going to memorize it. And for those who are wondering why we're not adding pi r squared, look at the question, guys. It's asking us to find the curved surface area, which is the curved surface area of the cone, so the outside part, excluding the base. Okay, so we're not going to worry about that circle. It's a hollow cone, so it's like a party hat. So I've got a equals to pi r s. You put in your values. Radius is 8 and s, the slant height, is 17, as we found just then. Just multiply it all out, you should get something like that. Okay, so make sure you really read the question and answer what they ask you to get. Okay, if you add pi r squared, you get marked down. Okay, so have a look at that and let's move on. Okay, question 8, starting with question A, it says 3 congruent open cones are to be made from a circular sheet of metal of radius 3 meters. So this is our circular sheet of metal and it says that the radius is going to be 3 meters. Okay, now with that sheet of metal, I'm going to make 3 congruent open cones. So see how the diagram shows us cuts within the metal? So I'm going to cut it into 3 parts like that, and then I can make 3 equal open cones. Because if I cut that one, this will be like a sector, isn't it? And if I cut that one, it looks like this kind of cone. Okay, so that's going to be what it's going to look like. And the question says find the surface area of each cone, correcting to 3 significant figures. Okay. Now, if I want to find the surface area, it's going to be open cones, so there's not going to be any bottom. So it's just going to be the outside area that I want to find. Now, guys, what I'm going to do to find the area of that, I'm just going to simply find the area of that open metal, that circular metal sheet, and then see how that part there is the area of that sector, which I'm going to make into a cone. So the surface area of the cone will be equal to the area of that sector, just one of the sectors. So what I'm going to do is simply find the area of the metal sheet. So it's going to be pi r squared, where radius is 3, and I'm simply going to divide it by 3 because there's 3 equal sectors. Okay, so I'm going to divide it by 3. Just put that into your calculator. You're going to get 9.42 meters squared. Okay, so that will be simply the surface area of that cone. Okay, all I did was find the area of one of the sectors. That was it. So hopefully that wasn't too bad. Have a look at that one. That's part A. Okay. Now part B. Calculate the base radius for each cone. So the base radius is going to be this radius for the cone, isn't it? Now, don't think too difficultly, guys. What I'm going to say, first of all, the slant height of the cone is 3 meters, which is the same as the radius of the big circle. Okay, the slant height is basically this radius of the original metal sheet, isn't it? Now, you should also know that the sector area, so remember how I told you that this is the sector in which I transform, if I like curl it and then make it into a cone, the sector area of that cone is simply pi rs. Remember that formula I told you? Pi rs. So the sector area is pi rs, okay, and I know that the sector and I know that that area is simply pi r squared, the area of the metal, divided by 3. Okay, that's what I did in part A, haven't I? But that should be equal to the area of the sector in which I use pi rs. But remember, the slant height is 3 meters, so s will simply be 3. These must be equal, wouldn't it? So all I need to do now is simplify it, guys. Okay, so let's just quickly simplify it. See how that one and that one would cancel, the 3's? Pi times 3 is simply 3 pi. And pi r3 is simply just 3 pi r. Okay, and I can just divide out both sides by 3 pi. Yeah. In order to calculate what r is, I would cancel that and I would cancel that. So r is simply just 1. Okay, r is left on this side, and 3 pi divided by 3 pi is just 1. So the radius of the base, that r, is simply 1. Okay, so how easy was that? Have a look. I'll rub this out for you. Okay, and that was the end of question 8. So don't think too difficultly. You can always utilize the original area formula in a question like this and just divide it out by 3 because there's 3 equal sectors. Okay, so that was question 8. Okay, question 9, it says the radius of the base of a cone is 6 meters. Slant height is 11 meters. Okay, it looks very similar to the previous question, isn't it? Now in part A, it says find the radius of the circle from which the curved surface was cut. Okay, so we want to find the radius of the curved circle. This is a circle and we're going to cut out a part. So we're going to cut that part out and make it into a cone. So it looks like that. And it gives us that the base radius is 6. So the little circle there has a radius of 6 meters. Okay? Alright, so if you want to find the radius of this circle, this is a slant height is 11. So the radius simply must be 11 meters. Okay? So this is a slant height, so this is going to be the center. This radius, as it says, as it's shown, is going to be 11 meters. That's all it's asking in this section, so it's very easy. Now in part B, it says, what is the circumference of the base? Okay, circumference of the base, it will be 2 pi r. So I did 2 pi times 6, because radius is 6, it's given to us. You just calculate it, put it into your calculator, and you should get 37.70 meters. Okay? And if they don't mention, just put 2 decimal place after it. Just round it off to whatever way you like, and then just write it down. Okay, so they can tell the teacher. Part C, it says how long is the arc of the sector from which the cone was made? Okay, how long is the arc? So we're basically calculating this arc. Okay, the sector. So same as the circumference of the base of a cone, because if I draw a base of a cone, base circle here, okay, if you close it and you get the circle as a lid, that circumference, the circumference of this circle, would be the exact same length as this arc, right? Because if we close the cone, that distance will be the circumference of that circle, isn't it? So it's simply going to be the same answer as part B. All right, 2 pi r, so 37.70, where radius is the 6. Okay, so I hope you understand why it's identical to part B. Now part D, it says calculate the area of that sector. Okay, so we're simply calculating the area of the sector. So it's going to be pi rs, you know that formula now. So pi times r, which is the radius, which is going to be 6. They put 6 here. And s, pi rs. S is going to be the slant height of 11. Okay, so simply going to be 207.35. You just put that into your calculator, you should be able to calculate that. Okay, so have a look at that, guys.